question is find the value of r for which the following pairs of equation yield a unique solution for p. Okay, so first this will be p square will be equal to q square. Okay, now this equation we have, we'll put p square. Okay, so we'll first of all we'll expand this, p square plus 2pr plus r square plus q square equal to 1. Okay, so p square is q square, so basically we'll write this as we can write this as q 2 q square plus 2qr plus r square minus 1 equal to 0. Okay, now see, for getting the unique solution, we will have to have this equation as a perfect square. Okay, then only we'll get a unique solution. Okay, so for being a perfect square, we'll plug in such r so that it becomes a perfect square. Okay, so if we plug in options directly, okay, so instead of plugging in directly, we'll do a little bit change and then we'll plug in. Okay, so this becomes 2 into root 2 cube. Now since we have to neutralize things, so we'll write r by root 2, and this will be r square minus 1 equal to 0. Okay, so this will become if now from here, first thing, since we have a positive sign over here, so r has to be a positive quantity. Okay, no, since we want, okay, yes, r may or may not be positive, r can be negative as well. Okay, but as such we have to plug in so that we get a perfect square. Okay, so what all options do we have? If we take so see, we have minus root 2. Okay, so if we put r equal to 2, what we'll get here now, we'll get root 2. Okay, so we'll get root 2 and here we'll get 3. Okay, so here we'll have 2 into root 2 into this 3, and we won't be getting a perfect square. Okay, so all the options with 2 gets eliminated. Okay, so now the other options which we have is this. The other options which we have is minus root 2 and plus root 2. Okay, so and let's check for root 2 plus root 2 first. We're checking. Okay, this will get this and this will become 2 root 2. Okay, so this gets cancelled and this will become root 2 whole square minus 1 2. Root 2 whole square, this becomes 2, this becomes 1. Okay, so this will satisfy this and we'll get a perfect square in this case. Okay, for positive root 2. Again for negative root 2 also we'll get the same thing. Okay, this will be the equation. So our this will look like root 2 cube plus 1 minus 1 equal to 0. Okay, so we got q equal to minus 1 upon root 2 in this case. Sorry, this is a minus, so plus root 2 in this case, and in this case we got minus 1 upon root 2. Okay, so since we want p and q to be positive, so this case is discarded. This is q now, q and p will be same, so this case is discarded. So we got q as 1 upon root 2 and our r was minus root 2 in this case, so minus root 2 is the answer to this question. Hope this is clear now.